Welcome back to our YouTube channel. Hi, this is Murli Thulam. Today's video, let us discuss about Kubernetes self-healing feature. First, let us see what is self-healing in the Kubernetes. Let us see. So why it is so important in the Kubernetes environment. So let us take one of the example. This is application, Amazon application. Here multiple services are there. These are all different services. Suppose if you are trying to set up your application with the Kubernetes. So this is the one you can see. Kubernetes. So we are trying to host our service in the Kubernetes, microservices. Example like Cell, MX Players, Amazon Fresh, Amazon Mobiles. These are all different services. Backend, we are going to host multiple pods for each service. But if anything goes wrong, the specific service, customer service, or Amazon Prime, if anything goes wrong, how Kubernetes is providing solutions? Let us see that. So for that, let us try to focus self-healing capability. This is the master node, and here you can see our pods. Okay. So here we are going to execute our instructions, kubectl instructions, and then we'll try to deploy our applications with worker nodes here. So here each worker node contains pods as well as multiple containers. Example, let us say Amazon mobile service, Amazon Prime service, or electronic service, different services you can see. If anything goes wrong, before going to the user, how to identify all these issues, how these issues will be resolved, let us see that. Okay. So this is the architecture, basic architecture, control plane or master node. So these are all important roles in this master node. etcd, API server, and scheduler, control manager. These are all important roles in the master node. And similar way, our worker node as well. So kubelet as well as kubeproxy, and also container runtime. So here, let us see one of the Amazon application we are trying to deploy. So here, with the help of kubectl or Helm, we are going to execute a few instructions. Then instruction will be read to first API server, and API server, it will receive the request. Then once it is done, it will send request to etcd. Here, entire cluster configuration will be stored here, desired configuration state. And once it is done, scheduler is trying to find out right worker node for this pod or application. And then control manager, so it is trying to maintain desired configuration state. So here multiple controllers are there. So multiple controllers like deployment controller, pod controller, node controller, cloud controller, different controllers are there. Stateful controller, different controllers are there. So with the help of this control manager, it is trying to maintain desired configuration state as for the etcd. Okay. So once it is request is processed, then through API server, request will be redirected to kubelet. Then kubelet will take care of lifecycle of your pod. Runtime, it is trying to create container, and after that, assigning IP address, right, and attaching volumes to proxy. It is trying to attach service as well, services and also endpoints. So whatever traffic you are receiving from outside and how to redirect this traffic to backend pods through services, kubeproxy will take care of that. So here, let us discuss about today's class. Let us discuss about only self-healing. So while using self-healing, these are all things you can see that self-healing capabilities, container level restarts. If any container inside pod fails, okay. So Kubernetes restart based on the restart policy. Let us see this restart policies also. Different types of policies. Always automatically restart the container after any termination or on failure. Right? So only restart the container if it exits, okay? Or never, does not automatically restart terminate container. These are all different policies based on your condition. You can set up that. So here, let us see our pod sample manifesto file also here, restart policies. These are all different restart policies. You can see that on failure, different conditions, you can see that. Or restart policy always. This is the first condition we discussed. Second one, replica replacement. So let's see this. Here you can see deployment. So here, this is the deployment. Let us see this deployment. If you observe this pod, on top of that, a replica set will be there. So here you can see a replica set. On top of this replica set, you can observe a replica set. Of your replica set, we'll try to set up our deployment as well. So here you can see deployment also. So this is the deployment, you can see that. So just see, if a pod in deployment or stateful set fails, right? Kubernetes, it is trying to create replacement pod to maintain specified number of replicas. So whatever number you maintain, so here, whatever number you mentioned, so within your manifesto file, it will take care of that number, desired configuration state. It is trying to create pod, so your worker nodes. And similar way, stateful sets as well. So if you are, whenever you're trying to use stateful sets for DB or messaging or some other scenarios, right? It is trying to create number of specific pods here. Same way, DaemonSet as well. If you want to observe these specifications, just see, this is the deployment. So here we mentioned replicas 3. And similar way, stateful set. Okay. Stateful sets also, here you can see that. So here we mentioned replicas 3. And also you can see DaemonSet as well. Right? So DaemonSet also you can see that. Okay. So DaemonSet, so here it is trying to create number of pods based on the nodes only. Example, if you are trying to create 3 worker nodes, if you are using 3 worker nodes, it is trying to create 3 pods, 3 DaemonSet pods for each worker node. So if any pod goes down, it is trying to create same pod in the same node, right? So in this way, DaemonSet also, it is trying to provide self-healing capabilities. At the same time, persistent storage recovery. Suppose if you are trying to create persistent volume, if node fails, right, Kubernetes can reattach the volume to a new pod on a different node. Right? So there's a persistent volume. Similar way, load balancing service as well. Right? Kubernetes automatically removes from service and endpoints to traffic. So with the help of your kubeproxy, here kubeproxy comes into the picture. Okay. So in this way, you can see self-healing capabilities as well. So here we can observe a very simple way. Kubelet, self-healing components, important components, let's see that. Kubelet, it ensures containers are running and restarts those whatever containers are failed. This is the first thing. Second one, deployment or replica set, stateful set, daemon set. So they are trying to maintain desired number of pod replicas. So these are all components you can see. Third one, you can see persistent volume controller. So with the help of this controller, it will make sure manages volume attachment as well as detachment for the stateful workloads, whatever stateful workloads you are using. So here it is trying to provide that. And while using this Kubernetes, so these are all things we need to remember, right? If any storage failure, okay, so we need to have some recovery steps as well. So we'll try to cover separate video recovery, right? And at the same time, application error also, right? So these errors should be addressed separately. Okay? These are all considerations. You can see that. Simply you can say, so with the help of self-healing, so if anything goes wrong, first self-healing capabilities, Kubernetes self-healing capabilities. So we'll try to identify the issues, and it is trying to resolve basic issues. In this video, we discussed about self-healing capabilities, and Kubernetes recently they launched 1.35. Within that, let us observe in terms of MLOps and AI-related few important options. Let us discuss that. Please see the documentation below. If you like this video, please share it and subscribe.